All right, another way to find the enthalpy of a reaction is by using what's called enthalpy of formation. So what are those? Well, enthalpy of formations are represented like this. They are delta H, so change in enthalpy. You'll have a little F down here, which stands for formation, and a little knot, like a little circle, like a degree symbol. You call it a knot. So it's delta H F knot. That's what the abbreviation is. So it's the heat of enthalpy, or heat or enthalpy, sorry, for the creation of a substance or the formation of a substance from its pure standard state elements. So the delta H formation of something is the amount of energy or heat required to make a molecule or an atom or something from its standard state elements, meaning whatever state they are at 25 degrees Celsius in 1 atmosphere, which is like general pressure and temperature. So it would be like, here, my examples here. So making salt from sodium and chlorine, it's individual elements. So sodium is a solid at room temperature, and chlorine exists as Cl2 gas at room temperature. I only needed half of that. So when I balance this to make 1 sodium chloride, the amount of energy associated with that is negative 410.9 kilojoules. So it actually gives off 410.9 kilojoules when sodium and chlorine react to form NaCl. This is called a delta H of formation. Same thing if I want to make, this is methane gas. Okay, so to make methane gas from its standard state elements, so the elements are carbon and hydrogen. Well, how does carbon exist at room temperature? Graphite, that's the most stable form, naturally. And hydrogen exists as a gas, H2 gas. So the equation is carbon plus H2 gas makes methane. Now to balance, you need a 2 here. So this is the formation for methane. That gives off 74.8 kilojoules for that reaction. So this is the delta H formation of forming methane. Now, delta H formations are actually things you can look up in a table, and I did attach this table to where the notes are here. So I would print it off for you. It's like the appendix in a textbook. You won't get it on the exam, but it's going to be really helpful for all of your math and stuff you're going to be doing right now. So you can look up these values for almost any substance. If we have made it, we have probably found how much energy is associated with making it. Okay, now I do want to note that any pure element, so carbon or hydrogen gas or whatever, in its standard state doesn't require energy to make. That's how it exists. So its delta H formation is 0. It doesn't take energy to make a pure element. Okay, so the delta H formation for like sodium, just plain sodium, is 0. Delta H formation for plain hydrogen gas is 0. Anything else has a delta H that you can look up. Okay, and you can see these on your table as well. There's some zeros on there for all of the pure elements. All right, so how do I use these to find the delta H for a reaction? Well, this is our equation. It's delta H equals, so for any reaction, the delta H is the sum of, this is an epsilon sign. It just means the sum of, meaning adding them together. The delta H formations of the products minus the sum of the delta H formation of the reactants. So you look up all the values for the products, that's the stuff on the right side, minus all the values for the reactants, that's the stuff on the left side, and that gives you the delta H for the reaction. Now, a couple of things, watch your signs. Okay, this is the biggest mistake that people make. Order of operations, use your parentheses, make sure your answer makes sense. It's kind of difficult, but this is actually a really simple, it's this add these minus add these, that's it. Okay, so there's a couple types of problems I can give you. First of all, I could give you, be like, calculate the delta H for an overall reaction if I give you all of the individual delta H formations. Really easy. Plug those in, sum minus sum, done. That's it. Now, I could also ask you to find a specific compound from a reaction, like what is its delta H F if I gave you the overall delta H. And again, that is still plug and chug and be like, I'm missing one of the products. You just got to solve for it. Okay, so I'm going to show you how to do both of these in the next 2 examples. If you're like, shh, I got this, go ahead and try your homework. So example number 7 says, find the delta H for the following reaction. So I gave you a reaction using the delta H of formation from the appendix value. So you need that appendix right next to you. You can download it or print it or whatever. So it's 4 ammonias react with 5 oxygens to make 4 nitrogen oxides or nitrous oxides and 6 waters. What is the delta H for this reaction? Well, I looked up the delta H values for all of these things. Okay, ammonia's delta H is negative 46.19. That's on the chart. Oxygen is its pure standard state element, so its delta HF is 0. Nitrogen monoxide is 90.37, and water is negative 241.82. So I have all these values that I just looked up. So the equation is delta H equals the sum of the products minus the sum of the reactants. Now you do have to take into account that they have coefficients. So there's 4 of these, 6 of these. Okay, so products first. Okay, that means the stuff on the right first. So I have 4 NO, so 4 times 90.37, added to, because it's the sum of 6 waters. So 6 times negative 241.82. So this is my 6 waters. I add those together. That's the sum of my products. Minus some of the reactants. Well, I have 4 ammonia, so 4 times negative 46.19, and oxygen 0, so it's 5 times 0, 0. So it's just 4 times negative 46.19. So then I do my products minus my reactants, and I get negative 904.68 kilojoules. If you do not get negative 904.68 kilojoules, go back and check your signs, okay? Be careful. You're subtracting a negative here, all right? Keep that in mind. Don't drop this negative, okay? Those are going to be important and change your values. Like I said, you could also have an example where I'm like, find the heat of formation. So that's delta H formation, a little F, for P4S3. This is a material found in match heads. It's not actually in the table. I want to know what it is. Using the delta H formation values from the appendix and the equation below. So in this case, I'm giving you the delta H for the full reaction. This value goes over here. That's the full reaction delta H. And then I can look up, well, this one's 0. I can look this one up and this one up, but I can't look this one up. So it's like products minus reactants. So plug and chug. This one, P4O10, I found in the table. And then I have 3 SO2s, so 3 times SO2s I found in the table, so products, minus, this is the one I don't know, so that's my X value, plus 8 oxygens, oxygen is 0, so it's really just minus X over here. Again, solve for X, watch your signs. I get negative 153.8 kilojoules per mole. That is the delta H for this missing one. Okay, and you are going to do one of these in the calculations in lab as well, so keep that in mind.